Hello guys, we're back with another question. NBHM 2019 question from analysis 2.3. Okay, so we're asked to find out which of the following statement is true. Log x is less than equal to x by e. Log x is greater than equal to x by e. E to the power pi is greater than pi to the power e. Okay, so first we see the third option. Okay, now if I suppose I want to prove this, if it had been true, this would be equivalent to showing that if I suppose x is less than y and I take x to the power a, y to the power, this will be x to the power a will be greater than y to the power a if a is positive, right? So what I can do is I can consider 1 by pi, this will be greater than pi 1 by pi, right? So what it will become is pi will cancel out. So it is, if I can show this, then it will automatically show this, right? So now this motivates us to consider the function x to the power 1 by x and its behavior, right? And basically its behavior, right? So we consider x positive. Let's suppose x is positive. Okay, so whenever you want to know whether this is study the range of a real valued function, so we first try to compute the derivative, right? So we will compute the derivative. So let it will be y. So log y log is 1 by x minus x derivative 1 log x. This implies that now thing is, if we take we are taking x positive, right? So this thing is always positive, this is also positive, so we just need to worry about this term. So now 1 by log x equals to 0. If we solve for dy by dx equals to 0, then what we get x equal to e, right? So we now what we do, we consider the sign scheme of f prime x, where fx is basically this one, x to 1 by x. So when it is 0, when x is equal to e at 0, now for let's take some point e square. Okay, e square. So sign of derivative will be e square. So log e square will be 2, 1 minus 2 negative, so it will be negative. Then put some 1 by e, let's suppose 1 by e is inside this, so 1 by 1 minus 1, so 1 plus 2 to positive. Okay, so what this says that this f of x, if you draw the graph, it will basically increasing then decreasing, right? So at e we have the maximum value, right? Now these are x to the 1 by x, this is for x positive, this is a continuously differentiable function, so we don't need to worry about differentiability and all those things. It can be seen easily since x is positive. Okay, so now what we have is so at e, basically at e it will attain a maxima, right? That means f of e will be greater than, now after e it is negative, so f of e is greater than f of alpha if alpha is greater than e, right? So in particular e to the power 1 by alpha I can take as pi, right? Pi is greater than e, so this is greater than pi to the power 1 by pi, so this is true. So option C is true. Okay, now for the second one, for the a and b part, consider the function e log x. So we take f here g of x, suppose this we take as e log x minus x. Similarly, as done in previous question, we try to find out the derivative of it. This is 0 when x is equal to e. Let's draw the sign scheme of g prime x. At e, so let's suppose if I put e square, e square 1 by e, 1 by e minus 1 is negative, so this is negative. And if I put some 1 by e, 1 by e, so e square minus 1, this is positive. Okay, for x positive I am taking, so this is 0. Okay, so again for this one also, this is increasing then decreasing, right? So for x positive, what we basically have is f of e is greater than or equal to f of x, sorry, g of e is greater than or equal to g of x, right? So what is g of e? G of e is basically e log e minus e, right, which is 0. This is greater than or equal to e log x minus x. This is for x positive, right? So what will happen then? This would imply x upon e, this is greater than log x. So option A is true, right? So A, C are true.